Greetings, dear viewer. Today, we're going to break down our Year 2 Technology unit that utilizes project-based learning and pair processing pedagogies.
Within the first lesson, students are introduced to the main content of the lessons. Students develop their understanding of algorithms and relate this to their real-world experiences. Students practice the important aspects of algorithms, for example, simple language, step-by-step instructions, and sequence.
In lesson, students are introduced to the new digital technologies of the Bluebot in conjunction with the iPad app that programs the robot. The teacher will also introduce key content terms such as hardware, software, and Bluetooth through exploring the different components of the Bluebot and the app on the iPad.
Lesson 3 follows the gradual release of responsibility model for student learning. The lesson begins with an explanation of the computational thinking process, followed with a demonstration relating to the activity where Lucy goes to school. Students then, with teacher prompting, perform an activity which demonstrates the use of the Bluebot in the we do phase. This activity allows students to develop the required skills which will be used in rotations later in the lesson. These rotations will prepare the students for the summative assessment because they will develop the skills which will be utilised, with some focusing on communicating how to move the Bluebot and others focusing on programming the Bluebot to follow where students want it to go.
The assessment task for our activity plan is a treasure hunt challenge, and this takes place in the 4th lesson. There is a task sheet and marking criteria that is to be explicitly explained to students at the beginning of the lesson. Students will work in pairs to complete the activity, although they will be assessed based on their individual abilities. Students need to help Bruce the Bluebot to get to the treasure chest to escape the island. To do this, students must first collect a map which helps them locate where the key and treasure chest is, followed by the key, and then they finish the activity when they arrive at the treasure chest. To extend the learning, students have the option to collect a bag and up to 4 diamonds on the way to the chest. Students need to think critically to determine the optimal sequence in order to complete this task. Students will also present their task to the class. This presentation will include a demonstration of their Bluebot and the path it takes in order to arrive at the treasure chest. They also need to identify and explain how they use the iPad to complete the task and discuss the process taken to complete the task, including a flowchart with their algorithm and any improvements that they have for next time or any problems they faced. It is essential that students begin to understand that digital systems need to be clearly told what to do in simple step-by-step instructions, and this is explored through role-play activities in Lesson 1. In Lesson 2, students are introduced to programming keys on the Bluebot, beginning to develop a basic understanding of how the technology works. This is extended in Lesson 3, where students undertake rotations to practice their coding skills. Within the final lesson, students adopt their understanding of coding learnt through the unit to program Bruce the Bluebot to escape the island. Students create the codes using the keys on the iPad app. By teaching students to code, they learn to problem solve and logically and critically think. Allowing students to learn to code encourages them to become creators of technology rather than just consumers. Computational thinking involves the thought processes used when formulating a solution to a problem that can be effectively carried out by an information processing agent. Computational thinking allows students to take a complex problem, understand what the problem is, and develop possible solutions. There is a clear process that must be followed for this thinking to be developed. This process involves decomposition, which is breaking the problem into small parts. Pattern recognition is exploring the similarities. Abstraction is removing unnecessary information. Algorithm, which is the creating of step-by-step instructions, and debugging, which is testing and fixing the algorithm. Within Lesson 3, the teacher first demonstrates the computational thinking process through Activity 1, which is helping Lucy get to school on time. The teacher then prompts students to follow this process through the We Do activity, which is helping Lucy get from school to swimming training, then to home. Students are then involved in a number of rotational activities where they can practice this process.
Within Lesson 4, students use the skills learned about computational thinking from the previous lesson to complete their assessment task. Students decompose the problem into smaller parts when they identify the different items to be collected before reaching the treasure chest to escape the island. This allows students to examine each step in more detail, therefore simplifying the process of creating the algorithm for the robot. Students recognize any patterns evident, which include getting to the items and the directions that could be used, for example, forward, left, right, and turning. This allows students to solve more complex problems more efficiently. Abstraction is evident when students carefully read the task sheet and highlight the most important details that are required to solve the problem. Students then create a flowchart of the algorithm they want the Bluebot to move in order to complete the task. Debugging is evident when students test their solution to see if it solves the problems. It If it does not, students debug their solution to find any problems that have occurred and fix their algorithm in order to improve their solution.
By the end of the unit, students will be proficient with the hardware and software components of Bluebot systems. They will be capable of connecting the Bluebot to the app via Bluetooth, as well as utilizing the app to program the Bluebot to follow directions. Students will also construct a flowchart that represents an algorithm needed to move the Bluebot to the required locations. They will present this work to the class. Strong connections can be made to the key learning areas of mathematics by encouraging students to count the number of spaces their robot will move in each direction using familiar number sequences. The students are also interpreting simple maps of familiar locations and identify the relative positions of the key features. In addition, the key learning area of English was embedded in the lesson when students prepare and present an oral presentation on their learning through the assessment piece, making use of digital technology vocabulary. Students are also listening and responding to a range of detailed instructions and content discussions, specifically in regards to the expectations of the assessment piece. Thank you so much for listening and have a great day.